Hey everyone, welcome back to the Math Lab. In the previous video, we saw how we could form an equation from this step graph that you see here. In this equation, we're going to do that visually using the power of dots. Let's get into it. So this time it's doing things visually, and it does require a little bit of creativity in order to solve this problem. So to start us off, I'm just going to draw this step pattern, but in a sequence of dots. Now we're going to fill this in a little bit in order to make rectangles, because we're going to be working out the hypothetical area of a rectangle using the dots that we see. So the first one I'm actually going to ignore for now because it's a little bit difficult to work that one out. For the next ones, let's just draw in some extra dots in order to make a rectangle. There's many ways to do this. The way that I recommend is to use the same amount of dots that you see to create the rectangle, so the other side of the rectangle. So we have 3 dots here, so I'm going to use 3 dots to create the rectangle. Here we have 1, 2, 3, 4, 5, 6, so I'm going to use 6 dots. Just like that. And hopefully you can see by now where the dots are coming from, and that it's just a reflection of the blue dots on the diagonal. And now let's go back to the first one. We ignored that one just for starters because we didn't really know what to do with it, what we were going to do. So now we can hopefully see that the dot belongs right there. So to work out the equation of the sequence, kind of imagine that there is a rectangle surrounding these dots. I'm just going to put a rectangle around all of these. So the first pattern in the sequence, we have 1 dot across and 2 high. In the second one, we have 2 across, and I'll just put little arrows here to say we're going across, and it's now 3 high. For the third one, we have 3 across and 4 high, and the last one is 4 across and 5 high. Now that we have all this, we need to define what our values are. So we have the number of squares and the number in the sequence. So this is n equals 1, this one is n equals 2, n equals 3, and n equals 4. We're going to ignore the number of squares that we covered last time for now, but we'll bring them in later on. We're going to now relate these numbers here to the number in the sequence. So this number on the bottom is that number in the sequence. 1 is 1. On the bottom here, this number 2 is the number in the sequence. The number 3 is, that's how far across it is this number in the sequence, and 4 across is the number in the sequence. So if we had an arbitrary number of dots, that would be, let's just draw out an arbitrary rectangle. And this rectangle would be n across. And going up and down, let's take a look at the numbers, the vertical numbers. We have here 2, but this number is 1. So we're 1 more than our number in the sequence. This value here is 3, which again is 1 more than the number in the sequence. 4, that's 1 more than 3, and 5 is 1 more than 4. To put that in an algebraic sense, if we have n here, 1 more than n is n plus 1. That's how tall our rectangle is. So, with that information, we can work out the size of this rectangle. And I'm going to call it area. It's not really area, but we're going to call it area anyway. Area equals base times height for a rectangle. And in this case, our base is n, and our height is n plus 1. But we're not done yet, because if we take a look in the pictures here, we started off with the blue circles, and we only want to end with the blue circles. Luckily, each of these rectangles we can now cut in half and end up with the blue circles. And because the circles represented the squares in the original picture, I'm going to use the letter S for number of squares for our final equation. And the number of squares is just half the area of the rectangle. So the area of the rectangle is half the area, half A, and A, we just found out, is n plus 1. Half n times n plus 1. And we're done. That is the equation for our number of squares. Now you might be thinking, wasn't this meant to be quadratic, or like with a power of 2? And there is actually a power of 2 if we multiply this half n by everything on the inside of the brackets. Now this might seem like it was an easy way to create this equation much faster than we did in the previous video. However, that's just because this was an easy step pattern for me. Other patterns, depending on their complexity, might take a little bit more brain work, and you might be just sitting there thinking for a long time, what is the pattern? And just keep in mind the easiest way to do this is by working out the area of a rectangle or even area of a triangle. We could have actually done this by working out the area of the triangles instead of the rectangles, and that would have prevented us from all of these pink dots. But we did it with rectangles, so there's plenty of different ways to do it. So as usual, I'll leave these notes down below so that you can write on them yourself, and I will see you in the next video.